Okay, so I'm just quickly going to go through the first learning outcome of the Year 7 Victorian curriculum in terms of data representation and interpretation. So if you are in Year 8, Year 9, Year 10 or above, this would be assumed knowledge. The first one that we're looking at is identifying and investigating issues involving numerical data collection from primary and secondary sources. Some elaborations for this are obtaining secondary data from newspapers, the internet and the Australian Bureau of Statistics, and investigating secondary data related to the distribution and use of non-renewable resources around the world. Now, these elaborations give us some extra information in that we can use the information collected by the Australian Bureau of Statistics to then make our own secondary data representations, and this highlights why we're teaching it in secondary schools. So some key vocab that we need to go through to make sure that we're all on the same page are these words here. Primary source of information is when the information is gathered by the person presenting the information as a means of answering a question that's been posed. So generally this could be just ordinary people, groups, or if we're looking at scientific data, obviously scientists who are asking a question, investigating a scientific phenomenon. Secondary sources of information is information that's being presented by people who have read and possibly interpreted the primary sources of data. So they haven't collected it themselves, and this is something we're going to talk about quite a bit in terms of why is it important to recognise that it may not be as reliable as a primary source of information. Data collection, so the processes that are used to gather the information through observations, surveys, etc. Raw data is any information that is given to you and it has not been filtered or processed in any way. Numerical data is data that is collected via measurements using tools, weights, scales, rulers, dollar amounts. Sometimes when you get into higher maths and science, it's called quantitative data because you can measure it with a tool. Categorical data is data that's grouped by labels or categories. So that might be what type of pet do you have, dog, cat, bird, etc. Another thing that we need to be aware of in statistics is bias. So the results from data collection that is not necessarily accurate for the whole population or creates information that may not be as reliable. So primary sources of data are generally gained through surveys, observations or measurements, so some examples of some questions that you could do yourself. What is the average height of a high school student? Measurements that you could take would be from your class, from your year level, from your school. What are the most common cars on the road? Observations, teachers' car park on the local street, the local highway. What is the most popular footy team in Australia? Survey your class, your school, your state. With these ones, you really need to question the information that's been gathered and related to the question that you've asked. So the fact that we've said the average height of secondary school students, we haven't said a year level, we haven't said where in the world, we haven't said any of those ones yet. Our data collection points are from our school. Same with if we were to go down and make observations of the road, of cars on the road. Well, if you're only looking at the teacher's car park, you're looking at a small socioeconomic group, and perhaps there are some people who aren't represented because their car is parked on the street or somewhere else. So we really need to start thinking about whether or not we are introducing errors into the information that we're supplying as well. In terms of the most popular footy team, well, I can guarantee that footy teams or favourite football teams are obviously going to change from school to school because different areas support different teams typically. So when you are reading primary data or gathering it yourself, consider the question being investigated. Is the data you have collected representative of the whole outcome? If we're interested in the average height of high school students, because it hasn't been clear, we'd want to be able to measure a range of students from a range of year levels from across the world. in terms of the most common cars on the road, if we just think narrowly, if we're just looking for in Australia, well, if you're in a rural area, there's probably going to be more trucks, utes, those sorts of things, and maybe less hybrids because there aren't charging stations, etc. Things to consider: the qualifications of the author. Is the author gaining something? So if for example, the one I typically use is, are you going to trust nutritional information supplied by McDonald's in the form of a graph? What is it that McDonald's is gaining from it? Well, clearly they're gaining your patronage in terms of eating their food, and they don't really want to tell you how bad it is for you. And where did the original information come from? Has it been collected fairly? Was there any peer review? Was it repeated? In terms of secondary sources, issues with secondary sources and why teach statistics, most media graphs and tables are secondary information. They are not done by the scientists who have completed the experiments or the observations. They are essentially a summary of those reports. So they have been filtered in a way, and depending on the professional integrity and the level of data comprehension of the reporter or politician, this may result in misleading information. So there's been some interesting instances where, and it's quite often referred to as cherry picking, or just not giving the full story so that you can make a point and not have people argue with your statistics, because you're technically not wrong, you're just not 100% right. So do consider whether or not, again, what is the purpose of the report and the statistics? Is it to sell a newspaper? So, if you're doing crime statistics and you want to sell a newspaper through fear, it's great to be able to put up how much crime has increased without perhaps taking into account that there's also been an increase in population, which is a common one. Is the author gaining something? So many reporters for large media outlets are trying to gain notoriety for themselves. A good example in Victoria would be Andrew Bolt. His statistics can be quite questionable. He does shock tactics in his reporting, and sometimes that's how he gains it. So people read him because they know that he is going to supply information like that. So is he deliberately picking information that will get him more headlines or cause more controversy? What are the qualifications of the author? Are they a scientist? Do they have any degrees in being able to read data? Did they finish high school? Statistics has only been taught in schools, high schools, for a reasonably short period of time, so it is something to consider. And then also, where did the original information come from? How was it collected? Was it peer reviewed, and was it repeated? So the same things we needed to consider in terms of primary statistics. So one of the reasons or the examples that's given for the Victorian curriculum is looking at the use of renewable and non-renewable energy sources around the world, and just drawing attention to the fact that sometimes there are relationships that can be formed. So for example, we've got a graph here that shows that Australia produces quite a bit of coal, or has a large amount of coal reserves. It's also, you can't necessarily see it because the video is in the way, is also, I'll just move the video for a minute, that we are the 8th highest user of coal around the world, even though our population is only 0.3 of the world population. So it's something to consider in terms of the source of information, and what relationship you've got between them. So a good source of primary statistics is to use the Australian Bureau of Statistics. It's a good way of making getting data for your own, to make secondary data presentations. And an interesting one in recent times was the same-sex plebiscite. It has quite a lot of statistics, and it goes into how it was collected and what makes it reliable. The next video will be looking at how to display data.